Moving on to 14. The following fragment intends that a user will enter a list of positive integers at the keyboard and terminate the list with a sentinel. Int value, final int sentinel, and this final means that that value can't be changed. It will forever be negative 999. So while value does not equal sentinel, and then you process the value and then read a new value in. The problem here is that you don't have an initial value. You have your value and then you process the null value. So what should have been done is this should have been up here. So that you set the value of value. So for number 14, it is D, because value is null at the beginning. Okay, so for this one, we have a cool little method that's really important to doing this really quickly. So for this one, you want to just convert each part into binary, that is. So first we'll convert 3, and that is 0 in the 8 place, 0 in the 4 place, 1 in the 2 place, and 1 in the 1 place. That adds up to 3. And then you have D. So D equals 1 in the 8 place, 1 in the 4 place, 0 in the 2 place, and 1 in the 1 place. So the way I found those was I just kind of converted in my head what D is equal to. So I know that A is 10, B is 11, C is 13. I just skipped a number. A is 10, B is 11, C is 12, D is 13. So yeah, D is 13. Tricking myself up there. But so you just convert the numbers into binary and then you convert them into decimal and then into binary, and that really helps out when just doing those little conversions. And then to just make it straight into binary from these two numbers, all you have to do is just concatenate them. So you have 0011, 1101. And that is A. Alright, so A. And for 16 on my sheet, it was a silly question review, and it was basically the same as this, but just a longer question. So I wanted to explain the concept. Okay, so this was a problem that I actually typed out myself. I think it's very important to kind of realize the significance of kind of how memory works. I'm not sure how important it is on the AP test, but if you want to go into computer science or are interested in it, then I think this is a really good thing to look at. So in Java, a variable of type int is represented internally as a 32-bit signed integer. So suppose that 1 bit stores the sign and the other 31 bits store the magnitude of the number in base 2. In this scheme, what is the largest value that can be stored as type int? So you know that 1 bit stores the sign. So you can only be as large as 2 to the 31 because that's how many bits there are. But you have to remember that, for instance, when you have oh no, this is just so awkward. Okay, so if you want to have a number, say you only have 1 bit of space, so that's 2. You have 1 or 0. So you can only go as high as 2 minus 1. So bringing that idea back into this question, you have 2 to the 31 minus 1, because you can't go all the way to 2 in this case, you can only go to 1, which is 2 minus 1. So 17 is, D is the right answer for 17. Now for 18, consider this code segment into x equals 10, y equals 0, while x is greater than 5, y equals 3, while y... Okay, so basically this is just another one of those ones where you have to go through and just trace the values, these values, through all of the code. So x equals 10, so 10 is greater than 5. Go on. So y is equal to 3 now. And I'll just keep track of that up here. So while y is less than x. So we have to remember to keep going through this loop rather than just treating it as an if. And then we have to keep going through this loop after that. So y times equals 2. So that means y equals y times 2, and we end up with 6. So if y mod x is equal to 1, and y mod 6 not equal to 1. So then we continue in this while loop, and so we do, since y is less than x still, we do y times equals 2. So y equals 12. And then if y mod x is equal to 1, which it isn't, so we don't do this code. We do not continue here because right now x is less than y. We then do x minus equals 3, so change this to 7. And then we continue in this while loop because x is still greater than 5. So y equals 3 again. All that work we did, worth nothing. So we then go in here while y is less than x, so 3 is less than 7. Y times equals 2. So y equals 6. So right here, if y mod x equals 1. Now this is kind of a tricky question with mod, but it ends up that you don't get 1. It's a little bit tricky because actually I think the remainder, it would either be entered, it would give it back to you as either -1 or +6. Probably +6, because 6 divided by 7 and the remainder is 6 because you didn't have enough for one division. So that doesn't happen. In conclusion, so then we go back to the beginning of the while loop. Y is less than x, and it is less than x, so we multiply y by 2, 12. Y mod x is still not 1, and then we continue, x minus equals 3, so x equals 4, and then 4 is not greater than 5, so we get out of this stupid loop. So then we have printing 4 and 12. And right here we see 4 and 12, so D is the right answer.